The next thing I want to show, if M and N are midpoints of the base and the summit of a security quadrilateral, then that line MN is actually the perpendicular bisector of both the base and the summit. So here I have my picture. I know that M is the bisector here, and N is the bisector of the summit. This tells me that AM is equal to MB. Angle A and B are congruent since by definition of the security quadrilateral, they're both right angles. We know that AD and BC are congruent by construction of the security quadrilateral. And we also know that angle D and angle C are the same since we have proved this previously that the summit angles need to be congruent. And finally, DN is equal to NC, once again by definition of N being the midpoint. So by side angle, side, we have that this left and right quadrilateral are congruent. This tells me that this angle AMN here has to be congruent to BMN here. And then once again, this DNM up here has to be congruent to CNM up here. And since both of these are supplementary, that means that they must be 90 degrees each. So that means that this segment is perpendicular to both the base and the summit, which is exactly what I claimed. It was the perpendicular bisector. By definition of the midpoints, we know it bisects, and now we have that it's perpendicular. And so these two quadrilaterals actually have 3 right angles, since we just stated that meant that these angles each needed to be 90 degrees. So this left and right quadrilateral have a special name. These are known as Lambert Quadrilaterals, and they're the quadrilaterals with 3 right angles. And in addition, if this side here, MN, is congruent to BC or AD, then this would be a rectangle.